Series circuit explanation. A series circuit involves just a single pathway through which current can flow. Above here, as you can see, is a series circuit. Current, when I connect this, will flow through the battery, negative terminal. The electrons will flow through the wire, in this case passing through a light bulb which offers resistance. The light bulb takes some of the energy, there will be a voltage drop here, to emit light. The electrons continue on their way back to the battery where they are re-energized and sent off again. Now this is with electron flow. Conventional current shows flow the other way, but the principle is the same. Now a couple ideas here that are important. First of all, the current flows in only one pathway. That's what makes a series circuit. The second big idea is that if there is a break in the circuit, then no current flows, since the pathway is broken. Another big idea to keep in mind is if there's no resistance in the circuit, such as removing this removing this light bulb, and connecting these together, we'll have no resistance, therefore a high amount of current running through here and causing the wires to heat up or the battery to heat up and an explosion. Let's put that back together here. Now, we can see how the current's flowing. First off, let's check a few of the things. In the battery, we can see that we have 9 volts. Through the light bulb, it offers a resistance of 10 ohms. By doing the calculation, we can see what the current should be. We could also grab this ammeter here and place it in series. To see how much current's flowing through here. And you can see it says 0.9 amps. That makes sense because the current should be the voltage divided by the resistance. Another thing that we can see is the voltage drop across this light bulb. Taking my voltmeter, I can place it here and here. What we'll notice is that we have a 9 volt drop. That makes sense. The battery is producing 9 volts of pushing the current, and here we're going to lose those 9 volts with that. Now, interesting thing is if we change and add another light bulb, we'll notice a couple things. First off, you can see that the lights are less bright, and that's because across each light bulb, and they're both the same, we are losing now just 4.5 volts of energy. So if I do that over here, now between the two, we can see the 9 volts of drop, but each one is pulling 4.5 volts. If we pulled another light bulb in, we'd minimize the voltage drop again, and the lights would become less bright, more dim. You can also see that the current has dropped, and so if we put in our ammeter, or let's just use the contact ammeter, which is a little bit easier to see, we can see that our current has dropped by half again. We're down to 0.45 versus our 0.9 amps. Now let's take a look at why this might be the case. Now, looking at a series circuit, we know that there must be only one loop for them to follow. And that was typical there. Now there are certain laws here. Kirchhoff's law shows that the current anywhere in the circuit is going to be the same. So if we measure anywhere at I1, I2, or I3, it will be same as the total current. And we could see that if we go back and check this out, anywhere in that circuit, our current is 0.45 amps. It does not change. Okay? Another thing to keep in mind is that for voltage, the sum of the drops will be the same, and it will add up to the total of the battery. So we can see here the voltage total is equal to V1 plus V2 plus V3. So the total voltage that the battery puts out will be the sum of all the voltage drops across all the resistors or lights or what have you. So in this particular case here, we'd see the 3 resistors, and those drops would have to add up back to that 9 volts. So if they were all the same, these resistors were all the same, which they are 100 ohms, they would produce a 3-volt drop at each one. So 3 plus 3 plus 3 gives us the 9 volts to get us back there. And again, we can see that by checking out our little diagram here, our model, that everywhere we see there's 4.5 volts there, and across this one as well, 4.5 volts. Across the total thing, there is 9 volts. Last thing to keep in mind is that the total resistance in the circuit is simply the resistance of all the resistors added up. So in this particular case here, we'd have 100 plus 100 plus 100 to give us the 300 for our total resistance. If we go back to our model here, we can see that this was 10 ohms and this was also 10 ohms. So if we added those two up, we'd have 20 ohms. And since this was 9 volts, 9 divided by 20, if we divide that, that would equal to our current, which we saw was at 0.45. That's the idea of a series circuit.